All right, guys, here we are back again, Mr. Hollins, with some properties of water for this biology class. The properties of water are varied. We have lots. You know, we can boil water. Let's write boil. We can freeze water. We can also have liquid water. We can wash with water. We can drink water. And so all the properties of the things that water can do, we want to take a look at and ask, so what is it that makes water such a special thing? One of the things that we know ice cubes do, ice cubes put in our freezer, and we know that the water expands. So we have this outward force, this expansion of water due to the shape of the water molecule. This is a little drawing we saw today. The little water molecule, it has one negative end and one positive end, and this is what makes it polar, is the fact that we have, you could draw a little imaginary line through here, and you could say this whole end here is positive, and this end down here is negative. And that's really what we mean when we say it's polar. It has two ends. Let's take a look at some other images of water and water molecules. Oh, let's see. Here's an image, and here's the oxygen and the two hydrogens, and they say it's a polar covalent bond. That's a good one. Let's see. Let's go back. What else do we have here? Here's another good one, and this shows oxygen with 8 protons, and it's 8 electrons, and then we have the hydrogen atoms they add on here. And it sort of looks like that funny little bear face, but we have more negative charges over on this end and we do on the other side. So there's a positive and a negative end. That's what makes it polar. Let's close that out. Let's go back. Take a look at another little model. Here's a nice one. This is what I had you draw today. So you have a model that kind of looks, well, what we think the atom or the molecule of water really looks like. Let's go back. See what else we have. I have a little video for you. If we take a look at salt in solution, and we have this salt, there it is. This is salt in solution, and so we have the green and the white things being the salt, and we add water. There are the little water molecules, and let's just see what would happen. How is it that water dissolves something like salt? So all those water molecules, when they're polar ends, start to attract these other salt molecules away from one another. And so this is what we call dissolving. And this is how water does it. It's because it uses its positive or negative ends to attract other molecules that have positive or negative ends themselves. Once this occurs, then we have it totally dissolved and you can no longer see it. That's called a salt solution. And now here's a little animation on the polarity of water molecules. So let's click here to start, and we'll see that they have a model they're going to use to indicate water. There it is, and there are the electrons and the nuclei for 2 hydrogens and 1 oxygen. Let's hit this and play, and so what we see is that we have an overall effect of negative on the bottom and positive on the top. See what happens next. And so then here we still have sort of like a big blob, the red part being the negative and the darker part being the positive. I think what they're telling you here is that the hydrogen bond is very important. Because water is a polar molecule, it is able to form multiple hydrogen bonds, which account for many of water's special properties. And in that figure 2.7, you see the red and blue water molecules all lined up based on this hydrogen bond. Next, one of your vocabulary words is cohesion, which is an attraction between molecules of the same substance. Because a single water molecule may be involved in as many as 4 hydrogen bonds at the same time, water is extremely cohesive. And cohesion causes water molecules to be drawn together, which is why drops of water form beads on a smooth surface. Cohesion also produces surface tension, explaining why some insects and spiders can walk on a pond's surface, as shown in your book on page 41. Next we have adhesion, and this is a little bit different than cohesion, but it is an attraction between molecules of different substances. Sometimes we see this when we read a graduated cylinder. The sides of the water climbs up the sides of the glass on the inside of the cylinder. And this is shown in your book on page 41. And finally, we have heat capacity. Another result of the multiple hydrogen bonds between water molecules is that it takes a huge amount of heat energy to cause those molecules to move faster, which raises the temperature of the water. Therefore, water's heat capacity, which is the amount of heat energy required to increase its temperature, is relatively high. This allows large bodies of water, such as oceans and lakes, to absorb large amounts of heat with only small changes in temperature. The organisms living within are then protected from drastic changes in temperature. At the cellular level, water absorbs the heat produced by cell processes, regulating the temperature of the cell. So here we go, guys. Now, test yourself on your use of vocabulary and see if you understand what we're asking. Question 1 is the attraction between the hydrogen atom in one water molecule and the oxygen atom on another water molecule is called, is that a covalent bond, a polar bond, a hydrogen bond, or the ionic bond? What do you think? Let's try hydrogen bond and submit our answer. Very good. It is the hydrogen bond. Here's a question. In polar molecules such as water, there's an uneven distribution of temperature, solvent, charges, or energy. Let's try this. Solvent. Is that it? No, it's wrong again. Try energy. Nope, incorrect again. Temperature? Try temperature. I said temperature. Click the arrow to proceed. In a salt solution, what happens to sodium chloride ions? They bond with each other to form a solvent. They become evenly dispersed in the water. They stay near the original salt crystal. Or they bond with each other, forming a new salt crystal. They stay near the original. They become evenly dispersed in the water. They bond with each other to form a solvent. Or they bond with each other to form a new salt crystal. I'm going to try. They become evenly dispersed in water. Let's just see. Yes. Guess again. That was a good one. Let's review a few major points. Because of the angles of its chemical bonds, the oxygen atom is on one end of the molecule and the hydrogen atoms are on the other. With 8 protons in its nucleus, an oxygen atom has a much stronger attraction for electrons than does a hydrogen atom with its single proton. There's a greater probability of finding the shared electrons in water close to its oxygen atom than near its hydrogen atoms. And as a result, the oxygen atom of the molecule has a slight negative charge and the hydrogen end of the molecule has a slight positive charge. A molecule in which the charges are unevenly distributed is said to be polar because the molecule is a bit like a magnet with 2 poles. The charges on a polar molecule are written in parentheses, negative or positive, to show that they are weak, weaker than the charges on the ions such as the sodium and the chlorine. Because of their partial positive and negative charges, polar molecules such as water can attract each other. The attraction between a hydrogen atom and one water molecule and the oxygen atom on another is known as a hydrogen bond. Water is able to form multiple hydrogen bonds, which account for many of its special properties. Hydrogen bonds are not as strong as covalent or ionic bonds, and they can form in other compounds besides water. Okay, so remember, boys and girls, water is your friend. It's a polar molecule. It's a solvent and it can dissolve things. And until we meet again, remember what Mr. Hollins says, read your textbook.